Hey everyone, so in today's video we're going to go over the revision for joining materials for the exam content. Just a recap of what you need to know from last year. So that is what's meant by term temporary and permanent processes, how you can join metals together, and how you can join timbers together as well. So MIG welding, so this is metal inert gas. That let you weld thin gauge metal, so nothing too thick. So the arc that you have makes you let you do a nice accurate little weld, so it's suitable for things like bike frames. So what happens is you've got your welding torch, and then on the inside, as you know, there is on the inside of the welding torch, you have got the electrode coming through. Okay, so the gas in the electrode causes the arc, and then you end up with your weld. Now, it's important to remember the wire that is fed through, because if you compare it to TIG welding, the key difference is with TIG welding, you've got the filler rod, which you apply separately. So this is suitable for stainless steel and non-ferrous metals. Because it's a two-handed thing and it's a lot more coordination required, it does require quite a high level of skill to do it. But it works pretty much the similar way, except for instead of having the wire fed through the welding torch, you have got the filler rod separate. The next is your oxyacetylene welding. So this was used before MIG and TIG was really a thing. So it will let you weld low carbon steel plates, things like that. What will happen is you've got a container of oxygen and a container of acetylene, and they are both attached with hoses to a torch, so they aren't joined to begin with. And then as you turn on the torch, both gases come through and mix together in the torch, creates a spark, and then that's how you will weld. The reason why it's not used so much is one, MIG and TIG are more effective. Two, it's a little bit dangerous because if they mix without a flame, they'll explode. So if you were to pierce or drop the bottles and they mix, you're going to get an explosion. But they are still used in places where you might necessarily get a good electric source. So if you're say in America in the desert and you've broken down, it's good for on the spot repairs. Same with if you're in another country where there's just no one around for quite a long way. So it does still have its places. It's just kind of being made redundant the more we go through. Brazing is another one that's sort of becoming a little bit obsolete. So what will happen is you've got your brazing rod, you have your two materials. Your two materials need to be flat and you will have to clean them. And then you'll add what's called flux to it. So flux stops the material from oxidizing, stops it from rusting. Then what will happen is you'll apply heat to where you want to join it. Then when it gets to the right temperature, you'll then add your brazing rod, and the brazing rod will melt into the gap where you want to join it and make your join. The reason why it's becoming a little bit less used now is because that obviously MIG and TIG now exist, but also brazing rod often is a different colour to the material you want to join together, so it has sort of an aesthetic problem as well. So soldering, used typically for electronics, but also in things like jewelry. So you have your soldering iron, typically get about 375 degrees. You'll have your circuit board, which is copper, and then the bits that you don't want to have electricity go through, the copper is etched away. You have your components. So in the example on here, you've got your LED. You have your two legs with your LEDs come through, and it's bent over the copper. You'll then apply heat, and then get your solder and touch it, and the solder will leave a little blob over where you want it to join. So on top of that, you've also got riveting and pot riveting. So pot riveting is becoming more common than riveting because you've got a rivet gun that makes it a lot easier to do it. It's a lot more consistent, whereas riveting by hand is less consistent and requires quite a bit more effort. You've then got self-tapping screws, machine screws, and nuts and bolts. And then timbers as well. So these are knockdown fittings that you typically get in flat pack furniture. So you've got things like battens where you have a block of material that you'll screw into the top and into the side to join them together. Your cam locks, which are typically used when you are wardrobes together, like the sides and tops of wardrobes. Plastic corner blocks, which again work in the same sort of way as the square battens. Rigid joints that let you join the tops of things together, so it's a little plastic triangle that's got holes in it that let you put screws in nice and easily. Then two block fittings. which again work sort of similar to the batten, except so the batten is attached to one piece already, and then you will attach the other block straight to the batten. So it's never actually officially properly attached to the other piece, you're attaching it to the other batten. So the benefit of that is that it's quite easy to take apart. So these are the knockdown fittings for timbers. There then are, of course, still like the self-tapping screws, and then there are the wood joints like finger joint, dowel joint, tail joint, all those sorts of things as well. So we're going to have a look at a couple of questions. So first one, match each of the components listed below with the correct joining method for the application given. So cam lock fitting, panel pin, self-tapping screws, polymer corner block. Again, next question, match each of the following components to the correct application in the table below. Self-tapping screws, dowels, corner plates, and pop rivets. So pause the video, give yourself a minute, answer them. So briefly explain 2 benefits of using knockdown fittings. 2 minutes, 2 marks, pause the video. So one, they make it easier to make furniture. They speed up the manufacturing process and cheaper to buy than handcrafted. You can also say the fact that anyone can do it. It doesn't include like specialist hand tools. Typically, it's just a case of using like Allen keys and things like that. So that is a revision cut on joining materials. If you've got any questions, send me an email or message me on Teams.